If f is a function with the domain A, then the graph of f is the set of the order pair x f of x, where x is in A, and plotted in a coordinate plane. In other words, the graph of f is the set of all points x, y, such that y equals f of x. That is, the graph of f is the graph of the equation y equals f of x. So here we have some basic shape of the graph and its domain. So let's start by taking a look at the first example, how to graph the function f of x equal to x squared by plotting. So I pick the value for x and then evaluate that f, and then evaluate the equation or the function at that value to find y. So let's say I choose the value to be -2, -1, 0, 1, and 2. And this value you can choose pretty much anything. Right? So then I'll evaluate f of -2. F of -2 equal 2 times -2 squared. That make 8. F of -1 equal 2 times -1 squared. That make 2. F of 0 equal 2 times 0 squared. That makes 0. F of 1 equal 2 times 1 squared equal 2. And f of 2 equal 2 times 2 squared. That equal 8. So this is the graph of x squared. So it's gonna have to be in the shape of the parabola. So let's see if that happens. So x equal -2, y equal 8. So here's our first point. Okay. Second point, when x equal to -1, y equal 2. 0, 0, 1, 2, negative, and 2, 8. So this graph is kind of like this. It's a very narrow parabola. And the domain of this function is all real number. And the range of this function, the smallest point here is 0 and the highest is infinity. We will choose the value for the table as follows: -2, -1, 0, 1, 2, 3, and 4. So in the first part of the table here, the value of x is less than or equal to, we use the part of the equation 1 minus x squared. In the second part, the value of x is greater than 2, so f of x is equal to x. So let's calculate this. When x equal to -2, plug into the equation, we get -3. Zero, 1, 0, -3. And when x equals 3, f of x also equals 3. When x equals 4, f of x also equals 4. So let's graph this. So when x equals 3, f of x equals 3. So we have this point and 4, this point. So we are looking at a straight line. When x equals -2, f of x equals -3. When x equals -1, we get 0. When x equals 0, y equals 1. When x equals 1, y equals 0. When x equals 2, y equals -3. So we are looking at this graph. Okay, so that is the graph of the piecewise function. Let's take a look at the vertical line test. A curve in the coordinate plane is the graph of the function if and only if no vertical line intersect the curve more than one. In other words, the given graph represents a function if and only if a vertical line only passes the graph by at one point. So let's say in the first equation, the first graph, well, here I can see that at x equal to -1, the vertical line passed the graph at 2 points. This means this graph does not represent a function. Whereas in the second one, if I draw a vertical line randomly to any of this point, it only intersects the graph at 1. So then this graph represents a function. So determine whether the equation define y as a function of x. Well, if we can solve for y alone, then that is a function. If you cannot solve for y by itself, then you don't have a function. So let's try to see if we can solve for y here. So here I was able to solve for y by itself. So here I have a function. Okay. In the next one, I'm looking at y minus 1 square equal 4 minus x square. So then y minus 1 equal plus or minus square root of 4 minus x squared. So note that here I cannot define y explicitly. Y cannot be defined explicitly here, so this does not represent a function. Let's take a look at our application problem. Westside Energy charged its electric customer a base rate of $6 a month plus 10 cents per kilowatt per hour for the first 300 kilowatt per hour used, and 6 cents per kilowatt per hour for all used over 300 kilowatt of electricity in a month. Okay, so here we have two situations. First situation that let x be the amount of electric that is used. And this in kilowatt per hour. Okay, that use each month. So if x is less than 300 kilowatt per hour, then the cost of the electric is $6 plus 0.1, that is 10 cents, times the amount of electric that used. But if x is greater than 300, if x is greater than 300 kilometer kilowatt per hour. Then the company will charge anything that over 300 kilowatt an extra 6 cents per kilowatt. Okay. So this is the portion that is 300 kilowatt. What happened with the watt mode of it? We x minus 300 kilowatt, and this will multiply by 6 cents. Okay. So the monthly cost for the function is the piecewise function 6 plus 0.1x if x is less than 300. If x is greater than 300, then we have 6 plus 0.1x plus 0.06 times x minus 300 for x is greater than 300 kilowatt per hour. We can graph this function using decimal. Our first piece of the equation is 6 plus 0.1x, and here for x is less than 300. And our second piece of the equation is 6 plus 0.1 x plus x minus 300 times 0.06 for the x greater than 300. So let's take a look at that piecewise function. So the the cost of the electric steady increasing to 300 kilowatt per hour, and then it's increased a lot more if you use more than 300 kilowatt per hour.